Welcome to the course Business Analytics and Text Mining Modeling using Python. So, in previous few lectures we have been discussing NumPy. So, let us start our discussion from the point we stopped in the previous lecture. So, we will talk about the vectorized array operations. So, it is about the element wise operations and it is about the vectorization aspect that facilitates faster execution and avoids slightly more lines of code using loops and other things that we typically can do using built-in and basics capabilities in Python. So, let us take this example. Suppose we want to perform this, we want to evaluate this particular expression where we would like to determine the square root of these two vectors, which are essentially 1D arrays here. So, Vx square plus V2 is Vy square, we would like to take a square root here for of these summation of these two terms, these two vectors, which are essentially. So, we can consider this these two as a two coordinate vectors 1D arrays. So, let us take let us initialize x as using a range function -5 to 5 and increment step would be 0.01. So, essentially we will be creating 1000 values here, x having 1000 elements, 1000 values, and y also will keep it same because the idea is just to demonstrate this aspect. So, let me run this and you can see in the output 338 and you can see this x, this 1D array, this vector or coordinate vector has been produced, and y will also be same. So, you can see this is quite long 1D array with 1000 values, right. So, you can see this from here. Now, if you want to look at the shape of this because I said 1000 values. So, let us confirm this. So, x dot shape, you can see 1000 elements there in this 1D array. Same thing we can do with the y also, y dot shape 1000 values, just to confirm what we wanted in the first place. So, now what we will do is we will create the coordinate matrices, the 2D arrays from these coordinate vectors. So, matrices, as we have indicating, these are similar to 2D arrays. So, these coordinate matrices will be 2D arrays and the coordinate vectors 1D arrays. So, from using these coordinate vectors we will produce the coordinate matrices here. So, let us say Vx comma Vy on the left hand side of this line of code, and we are using this function mesh grid function where we can pass on these coordinate vectors x comma y, and it will just produce a simple matrix kind of format using these two vectors. So, let me run this and the functionality of this particular function would be more clear. So, Vx comma Vy in this fashion, if I run this and let me have a look at the value Vx here, and you can see what we have in the Vx. So, essentially if you see what we had in x, so that has actually become a row here. This is a 2D array and that has become a first row here, and these rows are being repeated. So, in a sense the same vector has been used to create this mesh this grid kind of thing using the same values. So, all the rows are having the same values and we have just regenerated this 2D array using that 1D array by repeating 1D array multiple times as per the size of the second dimension. So, this is Vx. Same thing you can confirm using Vx dot shape. So, you can see 1000 comma 1000. So, this is the you can see this is the size of these two dimension of this 2D array. Similarly, for Vy also, if I run Vy, you can see here slightly different. You can see here the column wise. So, whatever vector that we had that has now been generated in a column wise fashion, you can see. So, a different matrix. So, using this mesh grid function we can produce we can use 1D array and produce 2D arrays with slightly different output, one row wise, the another one column wise. Now, we can recheck the shape of this also. You can see 1000 and now we can use the square to function sqrt function to take the square root of these two terms Vx to the power 2 and Vy to the power 2 and summation of these two terms, and we can take the square root here. So let me run this. So we will get this output, and again let's see the output here. So you can see that in the output number 347 for each of, so this is an element wise kind of element wise operations. So each element from Vx and corresponding element from Vy has been taken, squared, and then summed up, and then the square root has been taken. So in this fashion you can remember the values were around 5. So let us say it would be around 5 to the power 2, so around 25, then Vy around, so it will be around 50, and we take a square root, so the values will be around 7 something. So you can see most of the values that we have got in this output number 347, they are 7 is values around 7. So in this fashion we have been able to perform this operation. So this is a vectorized operation, and this is one example that we have got. We look at the shape of V, then this is 1000 by 1000. So we had those 1000 values there, 1000 the same shape there in Vx, same shape there in Vy, and the output also we have got the corresponding size here. So you can see the element wise operation has taken place, the vectorized kind of operation has taken place. Now let us take another example where we might be supposed to evaluate conditional statements. So let us create 2 integer arrays and 1 Boolean array. We would be using these arrays to take an example for conditional statement. So let me initialize these arrays here. So x1 we are using np dot array, and you can see 5 elements in this, and then y1 and then b1. So just some values here, and let me define them, initialize them. Now we will perform an operation like this this list comprehension, the next thing. So what we are doing in this list comprehension, we are picking x1 if b1 is true, and else pick y1. So in this fashion we would be creating this list comprehension, this list of values. So we are calling this reg, and let me run this, and let us see the output. You can see the values here 1.1, 2.2, and so you can check that back with the example values that we had in x1, y1, b1, and confirm the output also. Now what we will do is we will introduce another another function which is very useful, np.where function. This is a vectorized version of ternary expression that we have been using. So this output that we have just produced using list comprehension can also be produced using this np.where, which would work like a element which will perform element wise operations, and vectorization of the operation will happen, and the same result we will be able to achieve the same result. So let us understand what happens in this function np.where. So first argument is a conditional statement, and depending on the output of this conditional statement, which is going to be a Boolean output, true or false. So if true, then second argument will have the associated results, and the false, then the third argument will produce the associated results. So this is how np.where is going to work. So we look at the functionality wise quite similar to list comprehension. However, this is a vectorized version of the same, right. So this can work with n dimensional arrays, those kind of extended data structures in a sense. So what we are doing here is we are recording reg1, and on the right hand side we have np.where and b1 comma x1 comma y1. So here in a vectorized fashion this will happen. So if I run this, and you can see reg1 we have the same output. Now to demonstrate the power of this, we'll use it again later on in a 2D arrays or 3D arrays, using 2D arrays or 3D arrays. Now let's focus on another aspect. We'll create a new array where we would be conditionally transforming another array. So we'll use a where function again and conditionally transform another array. So let's create this array 13 to demonstrate this example. Array 13, these are the values 4 cross 4. It is a 2D array here, and if we type this conditional statement array 13 greater than 0 or not. So if I run this, we will get a Boolean array here, Boolean 2D array here. You can see false, trues, all those values here. Now we can use np.where function. So what we'll do in this, we'll set positive values to 2 and negative values to -2. So you can see np.where the first conditional statement is same that we had just run, array 13 greater than 0. So it will give us the Boolean output, and you can see it is 2D, no more we are dealing with 1D. So when we use the list comprehension, we can only deal with one dimensional data. However, when we talk about the vectorized operation using numpy functions, we can perform element wise operations, and therefore it is a kind of vectorized operation. We can deal with n dimensional data. So in this case it is 2 dimensional. So array 13 greater than 0, and for the true positive values the output is going to be 2, for the negative values the output is going to be -2. So if I run this, you can see output 357, and the array output, you can see all the values have been changed to either 2 or -2 depending on the Boolean output, right. So in this fashion you can see that using a conditional statement we have been able to transform the array. So this could be really useful in analytics context when we are performing certain data processing, certain cleaning or some other operations, manipulating data. So this could be really useful. Now let us take another example. Now this time we will set positive values to 2 and leave others as is. So in this case in the np.where function, the first argument is array 13 greater than 0. So any value which is positive, which is true, then we will assign 2, and otherwise we will keep the original value. So you can see array 13 we have indicated the original array to tell the function that will keep the value as is. So if I run this, and you can see the values changing here, any value in this 2D array 13, if anything which was greater than 0, that has been changed to 2, anything which was otherwise it has remained, it has kept its original value. You can compare this output 358 with the output 355. You can see the first value itself is unchanged. So that is how you should always confirm whether you are getting the output that you have desired. So it is always better practice to compare the outputs. Now let us take another example which is focusing on the mathematical and statistical operations. So you would now start getting the idea how this Python and these packages are really useful in performing these operations, because mathematical and statistical operation form the core of any analytics course. So you would start getting this idea from here onwards. So you can see now we are taking this example array 2d6, we are initializing this using random function. So let me run this, these are the values. Now if I want to compute the mean value across all elements, so we can use mean method here. So array 2d6 dot mean. So for all the values, all the elements that are part of this 2-dimensional array. So if I call this mean method, so I will get this mean value here as an output. Now we can achieve the same output using the mean function, numpy mean function here. So np dot mean, if I pass on this array here, so the same output will be able to achieve. However, this is this similarity ends here where we are just using all the values. However, if we want to let us take another example where it involves all the elements. So we will compute sum across all elements using sum method. So again dot sum, and we have got the value. Now if we want to take values from along first column, so in this fashion we can take array 2d6 and the bare slicing and comma 0. So we will get the first column here. So you can see now we can use again the mean method here, and we can pass on the axis if we want to compute mean along this first dimension and the column wise thing. So if I run this, I will get the output here, right. So along the first dimension. Now if I am looking for values along first row, so I can access like this array 2d6 and within bracket 0. So we will get these values here, and if we want to compute mean along associated elements of second dimension, then you can see in the mean method we are changing the axis argument here, x is equal to 1. Now it will help us compute the mean along the second dimension here, row wise thing. So if I run this, I will get these mean values for along the second dimension here, and we can use array cum sum method also to compute the cum sum values. So if I just run this array 2d4 here, these are the values. If I run array 2d4 dot cum sum, you can see how the cumulative sum is being produced here, that you can see. Now we can also use the cum sum method by indicating the axis. So along any axis column wise, then axis 0, so that can also be done. And the same method cum sum, we can pass axis 1, so it will perform row wise thing, cumulative sum row wise. Similarly product, cumulative product. So again we can pass on the axis and we can compute the cumulative product here. So array 2d4 dot cum prod and axis 1, and you can get the output. So in this fashion we would be able to compute the values along any dimensions. So different statistics that we just demonstrated here. Now sometimes we would be required to work with Boolean arrays. So how that can be done? So let us focus on a few examples here. So let me create this array 1D, this one dimensional array here, and let me create a Boolean array out of this. So if I run array 1D greater than 0, you can see we got the Boolean output here, and we can if we count positive values, we can do in this fashion array 1D greater than 0 dot sum. So this is certain certain statistics that we are computing just for the demonstration purpose. Now sometimes we might be required to check whether one or more values are true, so that we can use this any method that will help us find out in the Boolean array that we might have whether there is any true value that is present. So let us take b1. So this is the output. Now if we use this method b1 dot any, so this array method will give us this output here, true. Now we can, if we want to check whether all the values are true or not, then we have another method all. So we can call b1 dot all and we will get the output here. So you can see all these arrays that we have been talking about, some of these are 2 dimensional, and these methods are working with these 2 dimensional arrays and performing those mathematical and statistical operations and giving us the output. So you can see how it becomes easy to use these methods, array methods, and perform these n dimensional, multi-dimensional, element wise multi-dimensional operations. So now let us take another example here. Now these 2 methods that we just talked about, any and all methods, though we demonstrated it using Boolean arrays, they can also be used with the non-Boolean arrays. So let us take array 1 3, and if we apply array 13 dot any here, so if there are any non-zero values that are present in this array 13, which is a 2D array, so output would be, if the non-zero values are present, the output would be true. So in this case again, of course there are non-zero values, so true is the output. Whether all values or non-zero values here in this case, so we can use all method here. So you can see, because that is the case, so again we will get true output. So these methods, any and all method, can also work with non-Boolean arrays. Now let us talk about another aspect which is very important in the data processing context, in the analytics context, that is sorting. So we might have a sequence of values that we would like to sort. So let us understand how we can perform this here. So let us take this example array 1D. So these are the values, So, to sort these values and to perform in place kind of sorting, we can use this sort method. So, we can call array 1d dot sort and will produce in place sorting. So, in the array 1d itself the output is going to be stored. So, let me run this array 1d dot sort and you can see the output the array has been sorted and the original array has been replaced with the sorted copy of the itself. So, this is how we can perform sorting. Now, sometimes we might want to do perform the sorting along the dimension. So, that can also be done using this sort method. So, let us again look at array 13 and if we want to do sorting along a particular axis, let us say axis 1, that is second dimension. So, array 13 dot sort and within parentheses axis 1 and you would see in the output the sorting has been done along the second dimension here. So, you can clearly see that you can see the all the rows they have been sorted. Similarly, we have np dot sort function also. So, that will also perform this kind of sorting. So, it will actually return a sorted copy rather than doing in place sorting. So, let us take this example array 2d6 here and this is the output and we can actually perform this sorting here np dot sort array in 2d6 we are passing this as an argument and if I run this you can see all the values they have been sorted here clearly. So, this function can also be really useful to perform these kind of operation. Now, we might have we have earlier discussed about the quantiles and the sort function methods and function that we have just discussed, they can be really useful to compute quantiles. So, let us take a few examples. So, let us compute 50% quantile. So, what code we will have to write to perform this. So, let us take this array 1d and within the within the brackets you can see that what we are indicating here is that int type and 0.5 for the 50% percentile multiplied with length of this array 1d. So, in this fashion we will get this value here. So, if I run this and you would see that I have got this output minus 0.12 here. Now, if I run run array 1d and now you compare the output number 387 and 382. Now, you can see where this value minus 0.12 is lying in this array 1d. So, you can clearly see this is 6 value here. So, definitely this is 50% quantile here, half of the values are behind this value. So, in this fashion you can see very easily because the sorted array, the array 1d we had already sorted. So, on sorted array we had applied this. Please note this that array 1d when we typed this line of code 387, array 1d has already been sorted. So, on this sorted array we have performed this kind of indexing here and access this particular value 50% quantile value. So, sorted array can be useful to quickly compute the quantiles as well. Now, let us move further. Now, we will talk about certain operations, set operations on let us start with 1D arrays. So, let us take this example terms here and let us have a look at the values. So, in this we have this particular array we have used before also. So, alpha, beta, gamma, alpha, sigma, these are the values that are part of this 1D array. So, what we will do is we will discuss few set operations that can be performed. So, let us if we want to find out the unique values and we would like to sort them out. So, we will like to produce a sorted 1D arrays and also with the unique values. So, for this we have this unique function. So, we can use this np dot unique and we will have to pass on this this particular object terms and if I run this np dot unique terms, you can see in the output 390 you can see alpha, then beta, gamma and sigma. So, you can see these string values, this string array, this it has been sorted alphabetically and only the unique elements have been retained. You can see in 389 alpha was coming twice, right. Now that has been only, it is coming only once, and the first one, first element, first appearance has been retained, right. The second onwards appearances they have been removed and we are just left with the unique values and sorted array. Now similar thing we can work with the numerical arrays as well. So let me create this array 1D1. So let me run this and you can see in this array we have many values which are being repeated. So first element 5, then again 5, then 5, then 4, then 2, then 3, 3. So you can see few elements are being repeated a few times. So again we can, if you want to find out is sorted array with unique values, we can use this np.unique function and will be able to run this. So this kind of functionality is really useful in analytics context. To give you an example, for example you have a categorical variable and a categorical variable will have certain categories, certain labels. So all the observations that, all the cases, all the observations that you might have in your tabular data and for that categorical variable, so those labels are going to be repeated for different observations. So if we just want to, if we do not have the metadata with us, if we do not have the information about whether how many categories are present in a particular variable, so it becomes sometimes it becomes quite difficult. So using this function np.unique function, we will be immediately able to run this function on that column, on that vector, and we will be able to quickly find out the unique and elements and also in a sorted fashion. So sometimes it is going to be really useful in the analytics context. Let us again will in the next example what we will do is we will use sorted, we will use sorted and set functions, these two functions, to return sorted 1D arrays with unique values. So already we have talked about np.unique. Now these are few other functions that can be used to perform the same thing. So let us again have a look at the terms array here and you can see the output alpha, beta, gamma, alpha, sigma. Now I will use set terms. Now set terms will also produce the similar kind of output and a sorted array with unique values. So if I run set terms here, you can see we get the same output here in this as you can see here. Now similarly sorted function also we can use here. So set is giving us the unique output, then sorted we can combine these set and sorted function, and sorted function can be used to sort it out. So in this case it was already sorted in a sense. So however we can run this method, run this function sorted, and within parentheses set terms which will have the unique terms and that those will be sorted here. So let me run this. So you can see in the output 395 we have got the sorted. So first we will use set and then sorted and we will be able to achieve the same output that we got using the np.unique function. Now sometimes in certain scenarios we might be required to check the presence or absence of elements of one array in another. So a matching kind of thing and rather presence or absence kind of thing we would be required to find out. So that also let us see how we can do this. So let us take this example array 1D1 here, and if I run this we get this array here and you can see some values are repeated here. Now the function that can be used to perform this is np.in1d. So this function can actually be used to perform this. In the first argument what we are doing is we are passing array 1d1 and the second argument we have this list of values 0, 1, 2, 3. So we would like to find out whether any element in the first argument, that is the first array, whether any element in that first first argument, first array, whether it is matching with the elements of second list, that is it is actually a list here. So, we will get a Boolean output where if it is matching then true, if it is not matching then false. So, the output would be of the same size as the first argument, the array is, passed in the first argument. So, if I run this, you will get in the output 397, you can see first value in the output 396 is 5, which is not part of the second argument list. So, false. Similarly, for 5 again false, false, 4 is also not present, false, then true. So, that is actually the value is 2, which is part of the second argument list. So, therefore, it comes out to be true. So, presence or absence of elements of one array or list in another can actually be done quite easily using this particular function. Now, next aspect about arrays that we would like to discuss is about file management. So, file management we have discussed before also. How this can be performed using arrays, that is the next thing that I would like to discuss. So, this we will discuss in the next lecture. At this point I would like to stop here. Thank you.